Chapter 1, Section 6, Convert Customary Measurement Units. For this one, our content objective is for students to use ratio reasoning to convert between customary units of measure. We've got one brand new vocabulary word we're going to pick up in here, and that brand new vocabulary word is unit ratio, which is a ratio in which the first quantity is compared to one unit in the second quantity. Simply put, your denominator, your bottom number, is going to be 1. And with that, we are ready to start our new lesson. So, let's launch our lesson. And it comes with a really interesting introduction. It says that the systems of weights and measures have been in place since around 3000 BC or even earlier. Guys, that's 5,000 years ago, and then some. Different civilizations developed their own systems of measure in order to build houses, make clothing, make food, and trade for materials. The early Babylonians and Egyptian records show that lengths were measured by fingers, hands, forearm, and volume was measured using seeds, and weight was measured using seeds and stone. Your customary systems of measure were developed over time from the British imperial system, and while it is still the primary system of measurement used in the United States, we also use the metric system for international trade, and as much as my dad hates it, the metric system really is better in a lot of ways. It's got a lot of advantages to it. Now, converting between customary measurement units occurs often in the real world in everything from cooking to map making and to doing construction of buildings. So let's take and do a talk about it. Suppose you're making baked ziti for a family party. Now we got to put the brakes on here because I had no idea what a ziti was. I had to look this up. So let's find out what a ziti is. A ziti is this. It says it is a classic Italian-American comfort food of pasta baked with sausage, tomato sauce, and all kinds of gooey, yummy cheeses. Yep, okay, that sounds pretty good to me. So we're going to kill that off, and we're going to go back to our lesson, expand our screen, and keep reading. The recipe calls for 4 servings, but there's 16 people coming to dinner. How will you know how much of each ingredient to use? If the recipe calls for 2.5 teaspoons of oregano, how could you determine how much oregano to use in tablespoons, for example, for the total number of guests? This is the whole point of this lesson. This is a real-world use of what we're going to be learning in this lesson today and tomorrow. Now, before we can get too deep into learning the new material, you guys need to copy down this customary conversions chart because there's really important things in this, and you really need to have all these memorized. These are units of measure that you're going to use your whole life. So take a minute and copy them down because we're going to have them. Starting off with our length, 1 foot is the same thing as 12 inches. 1 yard is equal to 3 feet. 1 mile is equal to 5,280 feet. Who in their right mind, 5,280 feet? Why do they have this? And I don't know if you hear the chasing back and forth, but the cats keep chasing each other through the house right now. Under weight, you've got 1 pound is 16 ounces, while 1 ton is 2,000 pounds. There is no pattern that makes sense to the customary conversions, the customary system of measurement. The metric system's all base 10. It's perfect. It makes sense. Customary, not so much. And then we got capacity. So 1 cup is 8 fluid ounces. Meanwhile, 1 pint is 2 cups. 1 quart is 2 pints, but 1 gallon is 4 quarts. Not easy stuff to memorize because it's all funky and there's nothing common to it. But you can do it. I have complete faith in you. Now it says at the bottom, each relationship listed in the table is a ratio relationship. For example, there are 12 inches to every 1 foot. The relationship between the number of inches to the number of feet is a ratio relationship. The ratio of inches to feet is 12 to 1 with a colon, or 12 to 1 with the word to, but my favorite way to do it, they didn't show here, is 12 to 1 written as a fraction. A unit ratio is that vocab term we looked at earlier, is a ratio in which the first quantity is compared to 1 unit of the second quantity. Each of the conversions can be written as unit ratios. Some examples of unit ratios are shown. So, for example, inches to feet, 12 to 1. 12 inches to 1 foot. That's your unit ratio. The second unit's 1. Feet to yards, 3 feet to 1 yard. Second unit's 1. Feet to miles, 5,280 to 1. Your second unit is 1. What unit ratio can you use to represent between ounces and pounds and the other questions? Go ahead and pause this, and then we will come back and do check your answers. So you do it, check your answers, and we'll come back and look at it. All right, hopefully you got that pause. So, ounces to pounds. Well, let's see. There's going to be 16 ounces to 1 pound. Oops, wait a minute. We got something cool here. What is that? We're going to check on that. And, oh, wow, lookity. First time getting to use this. So, let's take and type it in. We're going to do 16:1 and accept. How about that? What unit ratio can you use to represent the relationship between pints and quarts? Well, what was it? I'm thinking it was 2. I'm not really good on that, but we're going to try it anyhow. So I'm going to say that there is going to be 2 pints in 1 quart. I think that's it. And then what unit ratio are there between feet and miles? Now that one I know solid. That is going to be 5,280 feet to 1 mile. So then we're going to accept that. Let's check my answers, and woohoo, I even got the middle one right. Moving forward to our next resource number 3. Convert larger units to smaller units. You can use reasoning about ratios to convert a measurement from a larger unit to a smaller unit. The numerical value of the measurement is greater when the smaller unit is used. To see why, consider the following problem. Suppose you want to know the number of fluid ounces that are in 6 pints. Now, we need to take a peek at that customary thing, measurement table. There it is. Now, what are we doing? We're going from how many fluid ounces there are in 6 pints. So, what do we have? Well, there's 8 fluid ounces in 1 cup, and there's 2 cups in 1 pint. And then we need to find 6 pints. So that's going to be some pretty interesting stuff. Now they have a think about it. Do you think the number of fluid ounces is going to be less than, equal to, or greater than 6? And why? Think about that answer. What do you have to say? I think it's going to be greater than 6 because, I mean, if you look at the chart here, 1 cup is 8 fluid ounces and 1 pint is 2 cups. So, I mean, you have double 8 ounces. So right there we can see there's probably going to be 16 ounces, I'm thinking, in 1 pint. But we need to be able to prove that with math. Either way, that is definitely going to fall in the greater than 6 category. So, moving along. Move through the slides to learn how a bar diagram can be used for customary conversions. So, first thing you need to do is draw your bar. After you have drawn your bar, then you're going to take and divide it into the 6 different sections because we have 6 pints. Okay? Now, each pint, of course, is going to be represented here. Each pint consists of 2 cups. So now my bar graph that I had 6 pints in has 2 cups listed in each one of those. But wait, that is not all. We also have to recognize how many fluid ounces are in each cup. Each cup is going to be 8 fluid ounces. Therefore, every 2 cups is going to be 16 fluid ounces. We good so far? So now we could take and say, well, how many fluid ounces are going to be in the 16 pints? Well, that's going to be 16 plus 16 plus 16 plus 16 plus 16 plus 16, also known as multiplying 16 by 6. And when you do that, you're going to find the final answer is equal to 96. There's going to be 96 fluid ounces located in 6 pints. I dare say that's a lot greater than the 6 that they had in the talk about thing. From here, we're going to move forward, and we're going to look at another way of doing this. This time we're going to use ratios and equivalent ratios. And we're going to move through the slides again to learn how to do this. Now, first thing we know is that step 1, we want to convert our 6 pints to cups. And we know that you can see down here, 2 cups is equal to 1 pint. And we need to find out how many cups, therefore, will equal to 6 pints. To do that, let's see what they say to do. Now, we did stuff like this in the last lesson, and I really didn't like how they came about it. They come up with these strange voodoo numbers here. So let's take just a minute. We're going to do a screenshot, and we're going to look at where all this is coming from. All right, we're all set up here. Let's start looking at this. Now, question is, where are these magic numbers coming from? You got 1s and 6s and 2s and 12s and whatnot. Well, the first thing we need to do is we need to take and convert the this right here, and we need to ask ourselves 1 times what is equal to 6. And you have that located, right here. Now you could have also done that like we did before, where we did 6 divided by 1 is equal to 6, which in turn gave us that 6 right there. So now we can say that 1 times 6 is 6. Therefore, to find out what the cups is going to be, we need to say 2 times 6 is equal to 12. And that's the reason that this C right here became 12 cups right there. That's where that 12 came from. Going back to the problems they gave us, we're going to hit the next button. And when we do, now we need to take and convert the 12 cups into fluid ounces. So from here, we have another problem laid out. We'll go ahead and hit the next slide so you can see what they said, and then I'm going to do another screenshot. And I've added that screenshot underneath my other one, and I'm once again going to help clarify where some numbers came from here. So we've got, get my pen going here, 1 times what was 12? Well, the answer to that was 12. 1 times 12 was 12, so now we need to say beneath that, 8 times 12 is going to equal to what? The reason I'm using 12 there is because I used it here, okay? And 8 times 12, when you multiply that out, you're going to get the 96, and that is the reason that your F value is going to become a 96 right there. Now, we're going to jump back to our main screen, and we're going to put our next button down, and at this point, using either method you came out with, you still got the 96 fluid ounces. Moving on to resource number 5. Now we're going to convert larger units to smaller units. Marco mixes 1/2 gallon of fertilizer with some soil before planting tulip bulbs. Question is, how many cups of fertilizer does he use? So you need to find out how many cups are equal to 1/2 gallon. What unit of measurement is being converted? Well, gallons are being converted, and what is it being converted to? It's being converted to cups. Next slide. Now we're going to take and move through the bar diagram, and we're going to look at all this again. You can see that on the bar diagram we have a full gallon listed, but only half of that gallon has been shaded, right? So now we've divided that bar graph into 2 sides, representing a shaded section representing 1/2 of the gallon. Of course, a gallon has 4 quarts to it. So now we can break that down into 4 1-quart sections that you can see right here. And now you can see how many quarts there are. But wait, we're not done. Now we need to break it down even further. We can see that there are 2 pints in every quart. So now because of that, you have 8 pints in a gallon and 4 pints in the half gallon we're working for. But we are not done yet. Now I think we need to find out how many cups are going to be in a pint. There's 4 cups in every, I'm sorry, there's 2 cups in every pint. That means there's 4 cups in every quart, which means there is 16 cups in every gallon. That's almost enough to make your brain explode, isn't it? But we are not done yet. We still have not gotten where we need to be because we need to find out how many cups there are in a half gallon. Well, to do that, all we have to do is take the 2 times the 4 cups located in a quart, and you see that right here. 2 times 4 is equal to 8 cups, otherwise known as 1/2 gallon. Now suppose Marco needed to find the number of cups that were in 1/3 of a gallon. Why might a bar diagram might not be the most useful thing? Well, because you can't really divide a gallon into 1/3 pieces. I mean, you can do that, but not involving things that are even numbers like 2 pints, 2 cups in a pint, and 4 quarts in a gallon. That doesn't divide into thirds very pretty, does it? Moving along. From here, we're going to use unit ratios and equivalent ratios, and we're going to do it a different way. Now, we're going to take again and look at it like we've done before. I'll go ahead and hit the next button, which is going to show what they've got, and then I'm going to do a screenshot. Now, this thing's going to take quite a few steps. The first thing we need to do is figure out how many quarts are in a gallon. And I know it's going to be kind of small on your screens, but you can see right here we've got it set up where you've got 4 quarts is to 1 gallon, as some unknown number of quarts is to a half gallon. Because of that, we need to say, well, or we also trying to find out how many quarts, how many quarts are a half gallon represents. So to do that, we're going to take and divide by 2. That you can see, hold on, right here. So the 1 gallon divided by 2 gave me a half gallon. That part's important because if I took this number 1 and divided it by 2 to get a half gallon, that means I have to take that number 4 and divide it by 2, and that means that I have got 2 quarts, and that's the reason your quarts became 2 right there. But we are just getting started on this. We've got a long way to go in order to get to the ounces. Did you notice that I changed my shirt? That's because when I was working on the previous part of this problem, it was Friday night. Now it is Sunday afternoon and we are back at it again. So just like you have homework every day, guess what? Us teachers, we have homework too. So, going into part 2 of this problem, now we need to convert from 2 quarts into pints. It says there are 2 pints in every quart, so the unit ratio for pints to quarts is 2 to 1, and you can see that listed right here. Now, we're going to go back to our screenshot again, and in our screenshot, we're going to work that out by hand. Once again, your textbook has made some big leaps here saying 1 times 2 equals 2 without exactly explaining why or where this is coming from. So let's take a look at what they have here. I'm going to zoom in just a little bit more here so we can see a little bit better how this is working for step 2. And on step 2, you can see that they have the ratio pints to quarts. You've got 2 pints is equal to 1 quart. So some unknown number of pints is equal to 2 quarts. And yes, I totally get that you can do this in your head. You still have to be able to use a big kid math and show us how it gets there. So what they did is they started off by focusing on, let me get my pen going, focusing on this row right here. They said, what do you need to do to 2? Let me change my color so it'll stand out a little bit here. Let's do a nice pretty green. We're going to this row right here. And make that a little smaller. So what did they ask? What do you need to do to 1? What do you multiply 1 by in order to get it to equal to 2? And that is, of course, going to be 2. 1 times 2 is 2. That is where they get that information right there from. Since you multiplied the 1 by 2 to get 2, you should also multiply the 2 by 2 to get your p-value. So 2 times 2 is equal to 4, and that is where that 4 came from that goes into your pints. Now once again, all this is giving me supporting work that I can use to justify where my answers are coming from. So we're going to jump back over to our textbook page. And on our textbook page, I'm not sure what just happened there. Let's go forward. Alright, we got it figured out here. And you can see that right here, they have listed that 2 pints are now going to be equal to 2 quarts. So with that, we're going to move on to the next slide because we're still not where we need to be. It wants to know how many ounces there are. So to find out how many ounces there are, next step is going to be to convert the 4 pints into cups. We know that there are 2 cups in every pint. And since there's 2 cups in every pint, we can make that a little bit bigger. That'll work a little better now for us, I think. Alright, now we're set up here, and that is where they get the relationship at, where they started off by saying that you had 2 cups. Well, let me get a screenshot. Alright, we got step 3 up on our slate now, and you can see on step 3, if I zoom in on that one, I'm going to zoom in, we're going to take and move it over to where you can actually see it a little bit. And on step 3, you can see that they set up the conversion ratio where they've got 2 cups is equal to 1 pint. And from here, they also have, you're going from 1 pint and you need 4 pints, because 4 pints is what we're working with right here where we're converting our pints to cups. So from there, you could say 1 times what number is equal to 4, and of course that is going to be 4. So if you multiply the bottom by 4, that means we have to multiply the top by 4 as well. 2 times 4 is going to equal to what? 8. And that is where the 8 is going to come from that you are going to see right here. Now right here you can see they've gone to 2 is to 1 as 8 is to 4. This is your good quality supporting work to go with it, and we can move on to the final stage. We now know there are 8 cups of soil being used here. I think it's manure being used in the problem. I forget what the problem actually says. And now the last step we have to do is we have to go from cups to ounces. So here we go. For our last step along the road, we're going to convert 4 pints to cups. One more screenshot. Oh, wait a minute, I'm confusing my problems. It looks like this one we only had to go 2 cups. So from there we found out that there are indeed going to be 8 cups of some fertilizer in there. So we're going to fill in our blanks. We're going to take and say that, so using either method, there is how many cups in a half gallon? The answer we came up with was 8, and therefore Marshall should use how many cups of fertilizer? I believe it's going to be 8 again. I'm not positive I remember the question, but let's go back and look at it. Yes, excellent. We did remember it well. We are going to stop this as part 1 of our video, and we will come back with part 2 of our video here in just a moment. Before we leave though, I do want to go back and look at our supporting work screen. So on our whiteboard here, when I take and scroll back out, you're going to see that there's an awful lot of supporting work that went into this problem. Whoops, too far. This is the kind of work I'm going to expect to see on your papers when you're doing these problems. You can't just say bleep, 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 oh yeah, the answer is 8. You've got to actually give me some multiplication, some supporting work to show where you're getting those answers from. See you on the next video.